Just a quick reintroduction. I was on the call earlier, but my name's James Duffy. We work over here at Energy Queensland. I've been in the design team now since about 2010, and probably about 3 years ago, we began a little journey towards some intelligent design tools. So we thought we'd take you through a bit of like our implementation of the tools into the business and some of the early adoption and what it looks like. I've also got Cam Harold here.
Afternoon all, Cam Harold. So I'm also with Energy Queensland. So I was looking after the substation design components on our design tool upgrades. So working closely with James and the team.
It is a little bit hard to hear questions on the call. So if you need to stop or shout out, just let us know at any point and interrupt, and we'll try to answer any questions as we go. We thought we'd give you a little bit of introduction to who we are. So something that's probably interesting for a lot of people is how big Australia is as a network. So you can see it overlaid down there across the United States. So we look after Queensland, which is that sort of top right portion of Australia. So we run the full sub-transmission distribution network for all of Queensland. So over on the left, we've got some stats for our network. So we've got 33 isolated power stations. So that predominantly deals with our remote island communities. We've got assets in 72 bulk supply points. So that tends to be where we interface with our transmission company over here. And then we've got 571 individual zone substations, and then a whole bunch of like little consumer industrial style subs under that. Our entire network covers about 1.7 million square kilometres, or I tried to put it in miles, not very good with the miles, sadly, but yeah, about 650,000 square miles geographic area. So quite a large area that we're covering. And that equates to about 250,000 kilometres of overhead and underground electrical network. So those numbers just give you a bit of like the understanding of how big our network is. And this over here on the right is sort of how our network's split up. So that southeast portion in the little bubble, that's probably our main population centre. And then the rest of the network sort of spread out as a much more remote rural sort of area. As with a lot of countries, the coast is a lot busier than inland. So I thought we'd sort of talk about why, because it's always an interesting question where like why change from what we've been doing. So EQL as a company was formed probably about 2014, I think was the original talk about this. From two legacy organizations. So I came from the Ergon Energy side, which was a company that ran effectively the whole rural side of the network. And it was formed off 6 legacy electricity boards. So quite a large variance, I guess, across those boards, and quite a big undertaking for Ergon Energy in the first pass through. And then sort of 20 years later, it was formed part of the EQL foundational organization. On the other side, we've got Energex, and that began as sort of 2 legacy companies down here in the southeast, like the main population centres. So as we sort of brought those 2 companies together, our key direction there was to try to adopt some common systems so that we can at least all work in the same systems. And then from that, actually gaining some common processes so that we can start to sort of work towards our mantra of design anything from anywhere, which is our sort of end goal. Fortunately, in some ways, both companies did run MicroStation as our predecessor software, and we were pretty much entirely in 2D with very limited 3D knowledge prior to undergoing this sort of journey. I thought I'd just take you through roughly what our architecture is, because that's sort of defined a little bit of why we've implemented and how we've implemented things. So over there on the left is our civil, structural, mechanical sort of teams. So they do all their base 3D modeling in Civil 3D for all their bulk earthworks, their hydrology studies. A lot of their output data comes out of AutoCAD architecture. That's mostly just for specific tool sets out of that tool, nothing specific to architecture itself. And then lastly, Autodesk Inventor. So we've got our own building manufacturing workshop here, and they've got probably 20 plus years experience inside Inventor. So very heavy Inventor users over there. And also in our power station area, all the mechanical designers are heavy Inventor users. So that was probably the part of the business, that civil, structural, mechanical world that had a bit of Autodesk skills. So what's new, I guess, is down the bottom and off to the right, where we've tried to pick up our primary and secondary skill sets into the AutoCAD environment. So obviously we're running Map 3D with P4A over the top. and then AutoCAD Electrical with PNC. We've also adopted AUD in our lines design space. So that was run as a sort of a grouped project, but in a separate stream. So part of that AUD implementation, they've built through the Utility Design Hub into our sort of new EAP software with SAP and into our new unified GIS system. So we're trying to get all of our systems across to unified systems. So it's been quite a big undertaking. And then sort of pivotal to all that is Vault. So Vault's our drawing repository of choice. Obviously, our Inventor users, it's pretty much required for them, that there's no other choice over there. So we've tried to adopt it company-wide, and that's becoming the sort of single source of truth for all our engineering output documentation.
Yeah. It's also all of our libraries and everything are stored in Vault as well. So all of our content for P4A, PNC, so on, it all lives in Vault.
Yeah, it's just really helpful having that single central repository as we work in, I think, 7 remote offices just in sub-design alone, and quite a lot more in the lines design space. Next, I thought I'd take you roughly through our project phases. So the sort of top 4 boxes took us between sort of 8 months and a year to get through. So it's a pretty short run through, a lot of work that went into this. But sort of upfront, we started with our sort of software refinement and configuration. So the key thing to start there with was content creation. So as I mentioned, we're predominantly MicroStation users as our background. So the first part of any content creation was learning how to actually drive anything in AutoCAD whatsoever. So that was a pretty big undertaking up front, was to sort of get those skills to create the content and then begin actually creating it. So with that, we were able to get quite a few users upskilled relatively quickly and sort that through the environment inside AutoCAD. Next, we kind of sat down and had to define what a common EQL requirement is. So that's been a pretty big undertaking for us coming from legacy companies, is trying to decipher what an EQL world should look like versus our legacy corporations. We also used this time to upskill some of our key SMEs. So we had a small team of 5 people on the project full time. So this is really where we bedded down those users and got them to sort of upskill and become quite proficient. And lastly, there's a lot of change management happening in this phase. So as you can imagine, with a lot of software changes across the organization, there was a lot going on. So we had some dedicated change management resources working with us to ensure that communication was kept up to date and to engage heavily with our designers, but also our end users, just to make sure they were all aware of what was coming and try to make the change a little bit less confronting, I guess, for our end users. Next, we moved into SIT testing. So this was sort of what we found as the key thing to bed down a lot of that original work that we did. So part of our SIT process, we had a 2-week dedicated time frame where we got a whole bunch of people and put them in a room and all work together. So we used that to upskill our next level of SMEs. So we went from the 5 key sort of starting points out into something like 15 resources in that SME band. We also use this as a great chance to do some bug fixing. So during this period, we're in still very early betas of P4A in particular. So quite a lot of workflows didn't get revisited once we sort of moved past them. So it was a great chance for us to find bugs in our configuration and also some software bugs as we work through it. Next, we use this period to engage our approving engineers. So up until this point, a lot of I guess the driver had come from our designers or our drafters. So we use this as a chance to sort of take our engineers through how the software works and the back end of it to understand what benefits they can start seeing from their side. So that's things like some electrical rules that run in there and even outputs and how they can engage with those outputs, a little bit different to the old 2D printed drawings. And the last sort of real key thing here is we use this as a way of defining our final sort of high level workflows. So working through with Jim Lucas from SBS, we sort of developed a brownfield and a greenfield workflow at a high level. We used this period to actually test that workflow through and sort of refine it as we went along. Next, we moved into UAT testing. So once we sort of passed through SIT, we went through a little cycle of bug fixes and just changes and sort of bedded down a lot of things. So then UAT testing was sort of like a catch-all at the end of that. So we used this one to basically test our end-to-end workflows. So inside PNC, we ran a very basic relay replacement, start to finish, off the two legacy corporations. And that was just a great way to ensure that generally the content was ready to go, but also that the users would have some workflows to work through at the same time as doing actual programmer works work. And then in the P4A side, we have a lot of legacy data in MicroStation. So that process was more about trying to get that data across into a P4A world and then do something really basic, which was just a circuit breaker replacement. So it's probably more utilizing the processes than it was the actual software at this phase, but pretty valuable again in developing some of our workflows for end users. Next was our Big Bang Go Live, as it was sold to us. So we kind of always aimed for a single date where we would consider go live. But what that really meant in reality was that was the day that we cut over to Vault. So we came from two legacy document repositories. We kept design running right the way through this period. So we had sort of like a 2-week cutover into Vault where we had to work offline. And then sort of that go live day one was when users switched on Vault and started using that as their day-to-day design repository. What this gave us was that ability to actually begin some real life projects inside PNC and P4A. So we sort of use this period to get some of those SMEs to oversee actual designers, as opposed to just using SMEs by themselves as a way of further upskilling some of our users. Lastly was sort of our first year of actual use. So as you can all imagine, that sort of first year of adopting anything is probably the toughest of the years when you're out in the business. So what we found really helpful was we ran some sustain, improve and fix workshops where we basically went through the entire project and looked for what worked well and then things that we want to keep focusing on, where we could get some quicker wins, and that was what like our improvements, and then the fix. What did we sort of need to take away and rework and try to actually redevelop workflows or interactions with different teams. So that really formed our feedback into our design tools. So from that point, we could use those feedback sessions to actually decipher where our configuration should push forward in both P4A and PNC. What that allowed us to do is hit our second generation of projects. So it really let us learn, I guess, through failing in some ways, and take some of those wins and successes forward into our next level of projects and change a little bit of our structures to suit. Another really key thing that happened in this first phase was our business awareness of our 3D modeling. So that was a pretty big step change for us, going from basic 2D drafting all the way to quite advanced 3D models. And we really had high engagement from our constructors on our first few projects, where they would come sit down next to our designers and actually get a real feel for the site well and truly before they hit any construction phases. It really allowed a much more I guess, accurate take on how they would achieve their construction and gave them a lot of definite direction with their outage plans and things like that prior to having to set foot on site. Next, we sort of thought we'd take you through our 5 key players. The main reason here is sort of the roles they played in the team were all quite succinct and definitely beneficial with the way we found it structured in the end. So we've had Cam here, who he effectively was the manager, managed the entire team and the day-to-day sort of running of our team. But then he was also the key representative from the Southeast, involved in a lot of the key decisions running forward into the project. He also took lead on the P4A configuration in particular. So we sat in quite a few meetings and sort of deciphered what we want to do going forward as far as EQL is concerned, with obviously his heavy background in the Southeast side. Sort of below, but next to Cam was myself. I was sort of Cam's equivalent in the North-South originally. So I was still involved in a lot of those key decisions, bringing my sort of North-South flavor to a lot of how we work. And I was a bit more involved in both P4A and PNC configurations because we did run our legacy companies a little different. Where in the North-South, our designers did primary and secondary layout work. Whereas the Southeast, it was a bit more succinct, where the certain designers would do layout, a different team would do their circuitry or secondary design. So I was trying to oversee both sets of configuration and also using this time to develop some of those high-level workflows. So that started out with just our basic content creation, you know, like what was important, how to get it in. all the way through to some of our like end level, how to actually achieve work and make it happen. Next was another North-South representative, Wes Norman. So as we got into this project, we realized it's a lot of work ahead of us. So we ended up splitting Wes off to just doing primary. So he oversaw our entire P4A content creation. So we had a few designers with a little bit of free time here and there that would create 3D content for us. So Wes was their single source of what to do and where to put their effort, as well as driving some consistency through their creation. Another main part of what he did was actually creating his own content. So he tended to do the more advanced, complex models, as well as sort of that overseeing role. Lastly, as we sort of started wrapping up that content creation piece and moving towards our training in particular, Wes sort of took over a lot of the really detailed workflows. And he was effectively our primary trainer, our lead primary trainer. So he ran a lot of our primary sessions with support of a couple other designers. So sort of at Wes's level, we had B Tao. So B comes out of the southeast here, and he's a circuitry designer. So he did the equivalent of what Wes was doing, but over in the PNC space. So with our PNC world, we had a lot more content that was required just due to the nature of secondary design. And we'd cut our entire communications department across our electrical designers, as well as our generation team designers. So we had sort of three different groups trying to work into PNC. So he sort of gave them all general direction about where to go with their content creation and tried to ensure that we weren't doubling up on any content across the teams. B at some point also, similar to Wes, cut over to doing some of those really detailed workflows, because as we sort of moved past the bulk of the content, it just became a really easy resource to get involved with those workflows, especially coming off the back of sit testing. And lastly, probably our workhorse was Bobby. So Bobby came in at a very different skill level to everyone else. He wasn't actually a designer. He works more in our sort of procurement space here. So he handled our day-to-day data entry. So if anyone's done it, you'd be aware there's a lot of data that needs to go into these tools. So he kind of took the lead on ensuring all the data from our legacy systems was coming across and going into the right tool in the right place, which was just a huge value to the whole team overall, because that's just a massive amount of repetitive work, and it really suited Bobby's skill set. The other thing that Bobby was really good at was testing our training workflows. The way we looked at it is if we could get Bobby to do it, we could get anyone to do it, because he came in with very limited CAD skills and no real design experience. So by using him as a sounding board for our training, it really let us bed in those training processes and make sure that we're going to work in the real world. And the last thing that Bobby took a real liking to was adding ports onto blocks. So that became one of his key roles sort of towards the end to ensure our content got out and published into the tools. So he became a very valuable team member. Probably wasn't really apparent up front that he would be so busy, but he was very busy the whole way through. So that was sort of our key level of users at the top there. When we hit our sit and UAT, we also had to go find some other users out in the business to bring in to do testing. So the way we selected those was to try pick the more moderate to high performers in all of our different offices. So we at least had some SMEs that you could go to and talk face to face in the majority of our offices across the state. So again, it wasn't always picking the best person for the role, but instead trying to put the location into that sort of decision making as well. Our next phase was training. This was quite a large undertaking for us. So with the size of our network, the fact that we were cutting across our telecoms, generation, and electrical teams, there was quite a few people that required training across the state. So we did actually roll this out across the state all at once. We kept our training to around that sort of 10 people. We found through some of our sort of test sessions that was a pretty good number to still provide trainer support without slowing down the entire classroom. Sadly, we started training right as a COVID lockdown hit. So our first couple of sessions ended up being switched to online training. And then we moved into in-person training from that point. It ended up being quite beneficial because it gave our trainers a little bit of a better skill set at working with that remote support. So when end users picked up the tool, that remote support felt a bit more natural. but it also let us sort of hone our original training in a sort of more controlled environment, which was, you know, sitting in your house, screen sharing and talking to people all day. Something that we found out of this was, in general, just mostly because of our skill set, I guess, coming into it, our P4A participants needed quite a lot more hands-on support from their trainers. So I guess when you look at the products on face value, there's a lot more happening in P&C, as in there's a lot more boxes and things to tick. But what we found with P4A, it requires a much better CAD understanding. And that was a big struggle for a lot of our users coming from MicroStation. They just didn't feel comfortable in the whole UI, let alone doing anything. So we found that the P4A side needed a lot more hands-on support, whereas P&C was a lot more dialogue box based, and you're kind of picking things off dialogue boxes. So it's a little bit easier to explain that to them than trying to explain sort of your basic AutoCAD functions at the same time as get across the intent of P4A. We did run dedicated sessions for P&C and P4A. So most users did both, but some users obviously just locked into their single discipline. So that kind of took quite a lot of organization, but also just meant that we were on the road for quite a long period and let us really hone down our dedicated sessions into each software. So sort of coming off the back of training was our go live. So the first thing we did was find an ideal project to move into the design tools. So there's a bit of a video here. I'll play in the background of our very first, I guess, project in the design tools. So we had two running concurrently, a north-south and a southeast job. So this one here is the one we ran in our north-south network. So the site here is a large mine connection. So this was a customer project, where it's a little bit hard to see with the slow rendering of the point cloud. But effectively, we've had to extend our yard 10 meters out in front of the site there and build out some 66 kV bays underneath some live conductors. So this was a pretty large undertaking. We ended up using a designer who had very little exposure to P4A up until this. So he kind of sat in his training and that was about it. So he got quite high levels of support through some of our SMEs, but it was a really good opportunity to sort of bed down some of our workflows and really test things out. So it wasn't an overly time-sensitive project, which is one of the reasons it was chosen. But also we had things like our point cloud data there. We had relatively good records of the site because it's a relatively new project that was probably only built in the last 10 years and used a lot of sort of existing equipment that we already had modeled inside P4A. So this job went, I guess, very slow, as both of our first projects were. They were probably what I would consider very hard work. And that comes down to us having to iron out a lot of our workflows, some of our bugs as we went through, as well as upskilling and training people at the same time. So effectively, we were all learning as we went through this. So you could very easily lose a couple of hours on something, you know, you'd consider quite mundane and straightforward these days. Some key things that came out of this was our engagement with our constructors. I'll just forward through one section of the video and stop it. But what was a real key part of this job here is as we're working in here, we had to leave the mine on. So I'm sure you all know that coal mines don't like to shut down for very long because they make a lot of money when they're running. So we had to keep this customer on as long as possible. So at the moment, it's supplied off a single 66 kV feed that's cut across into those two land over here on the right. So a key part of our consideration here is trying to build underneath what would be effectively energized conductors. So that's always a really big hazard and a big unknown until you sort of hit site and get working. That's generally where they really find out what it's going to be like. But being able to sit down with our constructors and just, you know, cut views of everything, take them through what the 3D model looks like. They can see how all the conductors are exactly going to be represented and above the conductors or the plant underneath them. It really allowed us to be very confident with our craneage, very confident with our outages, and really just drove the whole construction staging of this job to work quite well. Some other key things that just came out of this was just pure constructability. We used some similar foundations at a previous project that had only just passed through design. As soon as we drew it all in 3D and brought it into the model, we saw interfacing issues straight away. So that was quite beneficial for us because we managed to take that offline and go fix a previous project that was about to be issued out to the field. About to be constructed in the field, had been previously issued. So we managed to fix that up before it actually hit on site. There's nothing worse than the guys going to land something like a structure on top of the footing and realizing they can't actually do it. One of our really big challenges up front was our drawing presentation. So I've tried to cut through a couple of screenshots here to roughly show what we ended up with at our endpoint. Took quite a bit of getting to, but you can kind of see over here on the left in the clouded area, that's our 3D model. To the right of that is our old legacy 2D data. So up on the electrical plan view, it all came out looking relatively good. We were pretty happy with the end product there. But then down on our conduit plan, it was just felt a bit too busy. We really struggled with our representation of things like conduits. So it really sort of defined a lot of where we wanted to spend our focus going forward, trying to get these sort of constructible plans coming out of the tool.
Hey, James, I have a question real quick.
Sure.
Working under the live conductors, were you able to leverage like the clearance tools in P4A, like measuring against the point clouds?
Not the P4A clearance tools, because we didn't have any classification of the point cloud. So we were just using more of the basic point cloud measuring tools outside of AutoCAD.
Okay.
Yeah, but still doing the same sort of function, right? Just doing more manual measurements though.
Okay, cool. All right, thank you.
This led us to our second generation of projects. So we sort of moved past those first couple of projects after quite a few headaches, and I think a few of us came out of it feeling a little bit overwhelmed, I guess, with how much actually went into it. But we got there and we were pretty happy with the end product. So that brought about our second generation of projects. So the first one we hit was this motor park job. First thing you'll notice is no point cloud, so it's a lot smoother to look at on the screen. But one of the real key issues we found going through those early stages was performance. Our PC performance was just very slow, and it was caused by a few different factors. So one of the very early decisions made here was to cut away from any 2D data. So they went out and drafted any required 3D content of the existing legacy yards. So you can kind of see those landing spans as they are at the moment. They're all existing on site, and then the sort of greeny, as we call it, Herald green over here, the greeny colored plant, that tends to be all of our new plant in the middle. So that decision was made very early in the project and provided a lot of benefit to the modeling of this job. It made the modeling a lot more seamless. It made the outputs a lot more consistent and was generally quite a good decision. The obvious drawback is that time was spent upfront modeling that 3D data, where in the past projects, we'd just leveraged 2D information instead. So that was probably like our big win, had a job like this. It still showed us a lot of shortfalls in our workflows and data in general, but we just generally ran a lot faster than our first original projects. And what really worked here is, again, we had an end user that wasn't part of the initial rollout doing the design work, but he was closely shadowed by Wes, one of our sort of key users. And that really made that upskilling of the next generation of designers work really well. It might not look it, but some of the conduit modeling here, it was quite complex. So they had quite a few difficult workflows they had to go through. And just at a general level, this was our first full substation. So we've got the entire building, all the building internals in there. Mostly it's existing, but it's all been modeled in 3D, as well as that outdoor yard and even a comms tower there to the side. Sadly, this one hasn't actually hit the final stages. They've just moved over to the secondary design, so I don't have any output drawings to show. But generally, the quality has come right up again, even from those original Vermont drawings that we saw. So I guess looking back on that sort of first year post go live and the whole process up until that point, we thought we'd break down a little bit of what we found that went really well. So probably the first thing that went really, really well was our upskilling our SMEs prior to go live. The general consensus here is the more people who know what they're doing, the better, of course. But having those SMEs available and there to provide support really helped us upskill our next level of designers. The awareness, just the general awareness of constructability. So it's one of our key principles. We call them our COM principles: constructability, operability, maintainability. But constructability just becomes so much more obvious in a 3D world. And that was a really big step for us. So we really put a focus on detail early on in our models. We tried to find that right level of detail. And in some cases, it meant that we had to actually choose detail over performance. But overall, we found that's made quite a large difference to the constructability in particular, to ensure that we are seeing something that is pretty close to resembling what we get on site. Something else that went really well, we can't talk highly enough of SBS, is our vendor engagement and problem fixing. Pretty much from the start, any feedback we take to Joey and the team is always heard and listened to. And what it's really allowed us to do is deliver a much more straightforward workflow for our end users. So we've tried to keep that in mind the whole way through, is that just because the software can do it, doesn't mean that that's where we stop. We need to also focus a little bit on how our users are going to achieve that. The other thing that this really did was let us be a lot more aware of our end users internally and where they were finding struggles. So a lot of us had been in the tools for quite a long period at this point, and things that we were finding natural was for a struggle for our end users. So part of this vendor engagement and problem fixing, it allowed us to keep engaging with our end users and just really picked our remediation points quite quickly, whether they be workflows, content changes, or things that we fed back to SBS on the software side. Another surprising highlight of the overall tool is the lightning protection module and how it's been sort of deployed and used inside our company. It's very easy to adopt onto our existing data. So we've just run straight lightning protection modules now. So in the past, on our 2D drawings, I'm not sure how common it is, but our engineers would be getting their protractor out and just sketching circles on a piece of paper. So very rudimentary of the 2D drawings. So having that sort of the CAD software with the quick ease of modeling in 3D, even the lightning protection off basic 2D data, was hugely beneficial. The other thing we found is it works directly at the top of point cloud, because all you need is a couple of key points in there that are intelligent, and the rest of the data you can use off the point cloud as purely as a visualization aid. So it allowed us to do very quick, easy lightning protection on sites. And what it really became apparent for in the end was when we had actual lightning strikes damage equipment on site, we were able to run those scenarios through the lightning protection module and find some of the equipment that was struck was right on the cusp of being protected by a lightning protected zone, but then also allowed us to very quickly tailor that protected zone to ensure that they'd be protected into the future. So it's something that's probably had quite a lot of success in the company, and a lot of people are keen to use it. Our workflows. So our workflows sit in a few different places, but what went well about them was our workflow focus. So trying to always keep front of mind how our end users are going to achieve something. Because at the end of the day, it doesn't matter how good the software is, if our users can't use it, it's not going to get used. So we tried to keep that workflow focus, and it really made a lot of this adoption just go a little bit smoother for our end users, but also target the issues. And that was what was really beneficial about it. The last thing that also sits into a few places is our conduit design. So something that really became apparent very quickly is how much easier it is to visualize a conduit in 3D versus 2D, and where you start seeing issues with things like bending radiuses, underground clashes. So being able to do full conduit networks in 3D became hugely beneficial to some of our on-site construction issues. So next, we've sort of got our areas that we see some improvement could have been made or is being made. The first one's content creation. This is a really hard one. There's a massive backlog of content that we would like to see in the tool. As you can imagine, coming from effectively 8 legacy companies, there's a lot of different standards and plant structures and foundations across our network. So ideally, at some point, most of that will be modeled as we interface with it. But you can just imagine that's a massive backlog of data there. So it's just the sheer amount of content has been a little bit overwhelming for us. Something that's probably key to us is that we began this journey without knowing many people in a metric space doing 3D modeling. So we've effectively had to do it ourselves from scratch. And we found a lot of our manufacturers' data not always exactly accurate. They would use a lot of dimensions to represent what they would actually manufacture, but not give us full manufacturing models. So it caused us to spend a lot of time redrafting. The other thing that really became apparent in content creation is the level of knowledge we need in our people creating content to ensure that when it gets actually used, it's going to be very usable. Because whilst you can create content relatively quickly, it doesn't always come in and behave the way you want it to behave unless you get a few key things right. So I guess the big issue that this caused is that we had a few key people who knew what they were doing, and they could tend to slow down work getting pushed out because they were effectively having to do so much. The next one is workflow. So whilst our workflow focus went really well, what we struggled with was our actual workflows. So having physically documented workflows was extremely hard and still is, because it's very hard to have the right level of detail for every scenario that a certain thing happens. So that's something that we've really been trying to work through. And we're finding as people just get generally more skilled in the software, the need for these has dropped off a bit. But it has just been something that we've sort of noted from the start that sadly the best way to perform a workflow was to get someone to come over and show you how to do it in a lot of cases, because it wasn't always documented quite as quite the level of detail it needed. The other part of that is obviously the constant need for change. So we were all learning, still are, very heavily in this world. So a lot of our assumptions up front were changed over time. So that meant a lot of data being changed on our workflows. And then the sort of last thing here is our standard outputs. It's been pretty hard for us to get consistent 3D outputs going forward. So we're starting to get a lot closer to it now. And we had no EQL standard. And that was another really big, I guess, roadblock for us. It still is a little bit cumbersome at stages where we haven't got a defined EQL process yet. Some of our areas that we see needing a little bit more attention, I'll go through these a bit quicker because a lot of them are just sort of there at the moment. Our conjugate modeling, we need to upskill a lot more internally to get the level of accuracy there that we want. We've had a few visualization issues that have since been fixed in the product, but it's just generally caused a few issues throughout our early adoption of the product. Lighting design has become quite cumbersome for us. We've tried a few different off-the-shelf products. None of them work natively with our large 3D models to a point that they're overly usable. And if we try to adopt a product like Dialux, it requires quite a cumbersome process to get the data across there ready to go because it won't consume a native 3D DWG. Another really big issue for us is we're locked into 2020 AutoCAD. It comes from a few different reasons in the business, but the effective outcome is that we can't move off it at least for another 6 months. And that's causing us a lot of performance issues. So that's been a real struggle for our end users and has caused some delay in some of our adoption. The other part of that is our 2D models. So where we can't adopt 3D models quickly, trying to bring in and use all our old 2D data really slows performance down, especially as the substations get larger. So we've had to refine our workflows a little bit here, but the key thing we see here is getting off sort of our 2020 version into something like 2024, where they've dealt significantly with some of those performance issues. The next one, we just haven't had any success with geolocating. There's quite a few bugs and issues in 2020 with geolocating. Some of them are carried forward into some of the later versions. We haven't done much testing in 2024 yet, but it does appear a lot of those have been resolved. So it'll be sort of on our roadmap to get back in. That really allows us to integrate with our civil teams a lot more freely, as well as potentially start pushing data off to our GIS systems. And lastly is our sort of line style. It's just working with 3D polylines and solids. They're not as easy to show drawing intent as an old 2D drawing was. You had a lot more drafters license in the past. So that's kind of given us some difficulty in trying to get our intent out on our 2D paper drawings. In the interest of time, I'll go through this one relatively quickly. This is just sort of where we're heading next. So we've continued our heavy engagement with SBS. At the moment, we're sort of working through what we see as our problematic workflows. So we're sort of down to that 20% that we're trying to really refine. And just our general continuous improvement. We're trying to take quick wins where we can. Where we can't, we're trying to put things on a timeline and get them adopted where practical. One of our big ones, as Aman was talking about earlier on, was design sync. That's somewhere that we see a pretty big need for in the company. We're particularly worried about our cable data. So we're going to, at some point, hopefully start investigating using design sync as a cable database for all our multi-core cables, and see sort of where that can get us. The next thing that we're starting to really hit is our EQL agreed direction. So that's going quite well. Generally, we're trying to change a lot of legacy behaviors and opinions. So that's a pretty big undertaking, that one. But we're definitely trying to tackle it. Our point cloud leverage, we're finding point clouds so valuable. We can't sort of get enough of them. So we're just really trying to refine how we work with them internally and make that more apparent that we should be getting them more regularly. We've already talked about AutoCAD 2024. We're really keen to get that happening. We currently have some business cases running to try and get off our 2020 version. So that's a big key one for us. And our very last item there is hardware refresh. A lot of our machines are running sort of 5+ years in them. So we're in the process of trying to roll out some new laptops. So it's a bit of a move for us towards laptops for mobility. So we've tested some machines now with the new gen of i9 processors, running the new mobile ADA graphics cards and a 32 gig RAM setup, and it seems to be performing quite well even back on 2020.